Question number 13 from section 4.2. Solve the equation 3 to the 2x minus 5 power equals 9. My hint in doing these is to write both sides using the same base and then equate the exponents. On the left side of the equation, we have 3 to the 2x minus 5. Now this has a base of 3, so I would like to write the right side using a base of 3. 9 is the same thing as 3 to the second power. Okay, so since the left side base is 3 and the right side base is 3, then the exponent on the left has to equal the exponent on the right. So you can drop the bases and write this new equation that sets the exponent on the left, 2x minus 5, equal to the exponent on the right. Now you can solve this for x. Let's add 5 to both sides to get 2x equals 7. Divide by 2 to get x equals 7 over 2. You can check this with a calculator. See if the left side, if x is equal to 7 over 2, does that whole left side equal 9? You type 3 raised to the power, in parentheses, 2 times 7 over 2 minus 5. That equals 9. So we know 7 over 2 is the correct answer. And we could check 7 over 2. And doing these, you want to write both sides using the same base, and then set the exponent on the left to equal the exponent on the right. Question number 14. Solve the equation. Write both sides using the same base. The left side of the equation is e to the 11x minus 1, and the right side of the equation is e to the 9 to the x power. So remember the rules of exponent. A to the m to the nth power, power to a power. We can simplify this and write it as a to the m times n. So the left side of the equation we're going to write as e to the 11x minus 1 equals e to the 9th to the x. If you have a power to a power, you multiply those exponents and you can write it as 9x. We have an equation where the left base is equal to the right base, so this exponent on the left has to equal the exponent on the right. We drop those bases and come up with an equation that is 11x minus 1 equals 9x. Now we want to solve this for x. We can subtract 11x from both sides, and you get negative 1 equals negative 2x. Divide both sides by negative 2, and you get x equals 1/2. Okay, so when you plug that in back to the original, you can check that, plug it into both sides. The whole left side of the equation should equal the right side of the equation. So we're going to check 1/2 as our answer. Okay, let's look at number 15. Solve the equation. 64 to the 3x is equal to 16 to the x plus 2. Now both sides have different bases. We want to be able to write both sides with a common base and then equate the exponents. Now 64 and 16 are both powers of 4. So you may have to use a calculator to check different powers. Both of these bases, 64 is the same thing as 4 to the 3rd power, so we can write 64 with a base of 4, and 16 is the same thing as 4 to the 2nd power. So you can write both of these using that common base. We're going to write 64 as 4 to the 3rd power, in parentheses, to the 3x power, equals 16, which is 4 to the 2nd power, to the x plus 2 power. And what I've done here is that 64 to the 3x, I replaced 64 with 4 to the 3rd, and that 16 I've replaced it with 4 to the second power. Now you can use the properties of exponents. You have a power, a to the m to the nth power. Power to a power, you multiply those exponents together. And we're going to get 4 to the third to the 3x. You're going to take this 3x power, this third power multiply by 3x, and we're going to get 4 to the 3 times 3x, which is 9x. And here we're going to take on the right side the power of 2 and multiply it by x plus 2. Think about distributing that 2. And we're going to get 4 to the 2x plus 4. 2 times x and 2 times 2, you get 2x plus 4. Now you have an equation where the left base is equal to the right base. So you're going to set the exponent on the left equal the exponent on the right. It's like we're going to drop those bases. All right, you're going to drop those bases and set the exponent on the left, 9x, equal to the exponent on the right, 2x plus 4. Solve this for x. Let's subtract 2x from both sides, and you get 7x equals 4. Divide by 7 on both sides, and you get x equals 4 over 7. Let's check our answer. 4 over 7. Fantastic. Let's do another one. Okay, for question number 16, same hint, write both sides using the same base and equate the exponents. Now, both sides, well, the base on the left side is the square root of 3. So think of a base of 3. And the right side, the base is 27. Think about writing both of these with a base of 3. In fact, the square root of 3 is the same thing as 3 to the 1/2 power. And 27 is the same thing as 3 to the third power. So it is possible to write both of these with a common base. So just rewriting the problem, the square root of 3 to the x plus 1 power is equal to 27 to the x power. We're going to replace the 3, the square root of 3, with 3 to the 1/2 power. And we're going to replace 27 with 3 to the third power. Now we have a base raised to an exponent to an exponent. Think about those properties of exponents. A to the m to the nth power is a to the m times n. So let's write this as 3 to the 1/2 times x plus 1. Distribute that 1/2 and you get 1/2 of x plus 1/2 times 1 is a half. On the right side, 3 to the third to the x power. Power to a power, you're going to multiply those powers together to get 3 to the 3x. Now we have an equation. The left base is identical to the right base. So we're going to set this exponent on the left equal to the exponent on the right. We're dropping those bases to get a new equation that just sets the exponents to be equal. 1/2 x plus 1/2 equals 3x. Okay, let's go ahead and solve this for x. I can subtract 1/2 x from both sides. 3 minus 1/2 is 3 minus 1/2 is 2.5. We write that as a fraction as 5 over 2x. Use a calculator if you need to. 3 minus 1/2 and write that as a fraction or a decimal, either one. You get 1/2 equals 5 over 2. Now to solve an equation with a fraction in front of the x, you can multiply by the reciprocal. Multiply both sides by the reciprocal. And when you simplify this, 2 over 5 times 1 over 2, we get 1 over 5 is equal to x. So x equals 1 over 5, and we can check our answer. Again, And the key to doing these is to write both sides using that common base. The base on the left side needs to be the same as the base on the right side. Once you get that simplified, you set the equation, the exponent on the left, to be equal to the exponent on the right.